You've probably seen footage of what zero gravity looks like. It's usually depicted by astronauts floating around the International Space Station due to the lack of gravitational pull on their bodies. This is usually defined as zero-G, and it's a term that has been around for a long time. But it's an incorrect term. There's nowhere in the universe where there's zero gravity. The term microgravity is actually what's now being used to more correctly describe what's going on. Still, it doesn't exactly capture why astronauts float in space. First, we should ask the question, what exactly is gravity? Gravity is one of the 4 fundamental forces in the universe, and it's by far the weakest of the forces. We don't notice it pulling on us. The more massive a body is, the higher its gravitational pull. Gravitational pull goes down pretty rapidly the further you are from said object. If one planet is twice as far from the Sun as another, for example, it will feel a quarter of the force. But even though gravity might get smaller and smaller the further you are from an object, it never goes to zero. As long as there is mass, there is gravity. The International Space Station orbits around 400 kilometers over the surface of the Earth. It does experience less gravity than us on the surface, but only a tiny bit less. The gravitational pull of the Earth is still very strong. If this were not the case, satellites couldn't stay in orbit, and they and the Moon would simply fly off into space. The best explanation for this belongs to Douglas Adams. In his The Hitchhiker's Guide to the Galaxy series, he explains that flying is the art of throwing oneself to the ground and missing. And this is the correct explanation for the feeling of weightlessness in space. Satellites and the Moon stay in orbit around the Earth because they are moving very fast. The International Space Station moves at about 8 kilometers or 5 miles per second. The ISS goes around the Earth in just 90 minutes, and it's constantly being pulled towards our planet by gravity. If it were just magically placed on its orbit, without any lateral motion, it would simply come vertically down. But the ISS or anything else in orbit is moving. As it comes down towards Earth, it is also moving laterally, always missing our planet. The balance between the gravitational pull and the motion around the Earth gives rise to the free fall. The forces experienced by the astronauts are roughly balanced, so they're weightless. Gravity is still there, under their feet or their heads depending on their orientation, but they've learned how to throw themselves at the ground and miss, many times every day. Thank you for watching IFL Science, and don't forget to subscribe for more science videos.